Passwords and OTPs keep getting phished. Certificates integrated with ADFS give you phishing-resistant sign-in across all your federated apps. In this module, you'll see how to design, configure, and troubleshoot certificate-based SSO so it actually holds up in production. Certificate-based authentication, or CBA, is where PKI becomes very real for identity. Instead of proving who you are with a password, you prove it by demonstrating control of a private key bound to a user or device identity. That shift gives you strong phishing resistance, ties access to specific users and devices, and enables seamless single sign-on across both on-premises and cloud services. Think of this architecture as a trust bridge between your users and cloud services like Azure AD. External clients never talk directly to your ADFS farm. They first hit a web application proxy in the DMZ, which terminates TLS, performs initial validation, and shields your internal services. The proxy then forwards only legitimate traffic to ADFS, where authentication happens and tokens are issued according to your policies. Those tokens are consumed by relying parties, which accept them because they trust your ADFS signing certificates. ADFS relies on certificates for 4 distinct jobs. First, TLS or service certificates protect the endpoints. They provide standard HTTPS, so browsers and clients trust the federation and proxy servers. Second, client certificates authenticate the user or device to ADFS, often as part of smart card or mutual TLS flows. Third, token signing certificates prove that ADFS issued a token and that it wasn't modified in transit. Finally, token decryption certificates protect tokens that are encrypted for specific relying parties. When you enable certificate authentication in ADFS, treat intranet and extranet flows separately. On the intranet, domain-joined devices typically talk directly to the ADFS servers. Client TLS with certificates can act as a primary authentication method here without extra proxy logic. For external users, you normally front ADFS with Web Application Proxy. WAP doesn't terminate client certificate auth, it simply passes the TLS connection through. That means you configure WAP for pass-through and keep the actual certificate validation logic on the ADFS servers. Gatekeeping is where your IAM system decides which certificates it will actually trust. You first restrict access to a defined set of issuing CAs, so a random internal CA can't suddenly authenticate admins. Then you require specific policy OIDs and separate rules for user versus device certificates, so each certificate type is only accepted in the scenarios you intend. When you map certificates to AD accounts, think in terms of simplicity versus flexibility. UPN mapping is the simple path. You align the certificate subject, or UPN SAN, with the user's UPN in AD. It's easy to reason about and ideal for straightforward, one-to-one user logon scenarios. Alt security identities is the flexible option. You build explicit X509 patterns, can store multiple mappings per account, and can represent more complex setups like shared devices or layered administrative identities. The claims rule engine acts as the translator between certificates and IAM policies. First, it extracts identity data from the certificate, such as the UPN in the SAN, so it knows which account to associate with the sign-in. Next, it inspects the cert for assurance indicators, like a specific policy OID that represents a hardened issuance process. Finally, it turns that into simple claims, such as device is compliant, that ADFS or Azure AD can enforce downstream. Federation only works if both sides trust the certificates that protect tokens. Token signing certificates prove that SAML or OAuth tokens really came from your federation service, so any compromise here is catastrophic. Token decryption certificates protect tokens that are encrypted on the way back. When you use internal or non-public CAs, you must explicitly register and maintain those CAs in Azure AD's trust configuration, so it recognizes your federation tokens. Certificate rollover is about avoiding surprise outages. You start by continuously monitoring expiration, so you're planning months ahead, not days. Next, generate new keys and certificates under controlled change windows. Then update all relying parties via ADFS or Azure AD metadata so they trust the new certs. After that, swap the certificates on the actual services and endpoints. And finally, validate end-to-end. Test logons, SSO, and APIs before you retire the old certificates. To keep your ADFS and PKI-backed authentication stable, Treat monitoring as a first-class feature, not an afterthought. Begin by enabling detailed auditing. Log successes, failures, token issuance, and configuration changes. Those events become your forensic record when something breaks or is attacked. Then, watch performance counters for queues, latency, and error rates so you can respond before users notice issues. And stream everything into a CM like Microsoft Sentinel, building alerts for unusual patterns, not just hard failures. When you troubleshoot certificate-based sign-in, work from the client outward. Start at the browser or client. Confirm the certificate is present and valid, the chain builds correctly, and EKUs match the scenario. Next, check the network path or web application proxy. Verify the TLS handshake and that the client certificate is actually reaching the Federation service. Then analyze the ADFS server. Mapping failures, issuer mismatches, or revocation errors usually show up clearly in Event Viewer. Finally, validate the relying party. Inspect tokens or SAML assertions and look for any trust or signature errors. When you integrate PKI with ADFS, treat identity mapping and certificate design as a single system. Ensure certificate subjects and SANs line up cleanly with the attributes ADFS uses for account mapping. Otherwise, you'll chase hard to diagnose login failures. Automate token signing certificate rollovers and monitor them like any other critical change, with alerts and documented runbooks. And strictly control which keys ADFS trusts, so only certificates from your approved issuers can authenticate.